right to right and left to left. First we will create some project. Here this I have already created one project. We will open this one. Let's start. Open the project view. In previous lecture we will discuss about shift registers left to right and right to left. This PLC I'm using, and I use that program logs, main OB, and now that we make simulation with S7-1500. It took little time. And then click load, and then click finish. And make it simulation on, and let's save it here and make it the PLC in run condition, and see how we can use. First, if I make the simulation of, I will give to little demo for that command. That in here. See, first we discuss in previous lecture we discuss about shift right and shift left. Now we discuss about this rotate right and rotate left. This command is I use this rotate right, and I make it one pulse for M0.0 to giving the pulse for temporary only learning purpose. And here I use some internal memory relays M0 1.0 to 1.1, M.2, 1.3, 1.4, and we will make it one more here. We will take a branch, one more branch, and here we use one contact, and here also one more contact, here one more contact, and this we will give name that M1.4, M1.5, M1.6, and one more have remaining for, sorry, this have to take branch first, 1.7, because of every and each byte have 8 bits. When we're using that 8 bits data, that I'm using that condition byte, and I use the first data of the data registers MB1, and I will make it also and take result in MB1, and I'm used M1.0 means MB1 of the first serial M1.0 yani. And this is now total our total 7 yani 1.0 from to M1.7. This also we will make serial, no problem. Q0.0, that's we will make Q0.1, and that we will make Q0. Q0.2, and that's we will make Q0.3. That means when serial made after, in learning we will easy to learn, yani Q0.4, and next we will use it here. One more relay here, one more relay, one more relay, one more relay. Q0.5, Q0.5, Q0.6, Q0.7, and we make 1.0. Q0.0 is 1, 2. This 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. This is only Q up to 0.7, yani means how much it's our total now came 1, 2, 3, yani here up to 7, yani up to 8, yani 7, 6, 5, 4. This is 4 pieces. The total from Q0.0 to Q0.7, it's total 8 bits, yani this is an extra. This is we will not use. I will put at any name, yani Q1.0, no problem, but this no need. We have to be learn only purpose. And see, this I download the PLC. What's the function we have to be understand about this command. Now I make this one, and this area, this when you're using that command ROR, here you have to be defined, yani how much you data you like to move, yani I will put it here in decimal hexa 80. If I write, it means that first bit of the 1 byte, yani, and how much likes to move, yani here you have to be defined 1 or 2, any means couple of bits you want to transfer or rotate, yani means after you have to be used that here 1 or 2 or 3 or 4, how much, and when your data register increasing here, after you have to can be increase it here data when. And also one more, we will take one force table after you understand easily. I will make it this small. This we will take it here, and this we used MB1, yeah, that's okay, and we will make it this one. See, when I write it here 80, it means this first bit, yani first thing or 7 which you yani keep in mind, yani this is the first number, yani this is in hexa value. When put it in binary or something, this value will be another. When I give one pulse here, see, now that first bit moves to the next, and when I give one more, first I have to be stop, and next I will give it go to the next yani. This is 6 number yani bit. This is 6, this is 7, this is 8 bit. Yani start from this side. If this is from this side start, Q0.0, Q0.1, or anything you can M100.0, M100.2, or which yani bit you using here. MB1 for example, this byte of the first bit is M1.0. M1.0, M1.1, M1.2, 1.3, 1.4, that's 1.5 is on now. And also this bit we can see it here in our out bits yani. When 1.5 is on, after 1.5 energize the Q0.6 because of it's rotating right from side to right yani. When I give the next bit, it will be move forward into the Q1.6. We have to go. This is now in true condition. Make it first 0, and then giving next. When give, it will be moved to Q0.6. See, that's it moves. M1.4. Oh, sorry, it's a little bit wrong. We made Q1.4 would double used. When we 2 bit used one name, it will be energized one yani. But now it's running yani. Q1.4 is running. M1.4 means now make it 0. This also you can use it here, pulse timer. Also you can use it here, any signal from outside. For example, in field when you're using this command, then maybe one sensor is sensing for your bottles, for 250 ml bottles. There is a many type of bottles if you are using yani, in size different for filling water or filling juices or something. When you put the signal, one signal you can put for this one signal M0.0 or I0.0 when you write it here. And from field coming the signal I0.0, you can use the one signal for 200 ml 50 ml bottle. And if you use for that one next signal also, you can use it when you make the programming. You can use another I0.2 for example, that you can make it for next bottle yani 500 ml or 600 ml, which when that signal comes after yani, this data moves. When this signal comes, this data moves. This next in your program slowly inshallah will be next lectures. I will explain you more. Now see, that's we give one more signal, it will be goes to the right side yani. When right side go, our next yani Q1.5, no sorry 1.3. See 1.3, because of this is start from this side yani, it's moving right to right. This is M1.3 yani, this is M0.0, M0.1, M0.2 and M0.3. Now as our M1.3 is energized. When you giving this next signal, it will be goes to in next yani M1.2. and when you giving next one more signal, make it stop and give one more signal. Now it's energized M1.1. Now when you last giving that M0 false, and as you giving the signal, that M1.0 will be energized. This is your first yani bit starts from right to right register. This is M1.0 on. But what's the interesting thing, in previous uh, command we used, this is only moving the yani bits in left to right or right to left. But this is what interesting, as I giving one more signal, see, it will be go back to the first bit, last yani Q0.7 M1.7. see, as I giving last bit, it rotates yani means to the goes to the last M1.7. after serial wise this will be continue, make it true. When you give it next signal, it will be moved to the next forward. See, it go back to the M1.6. Yani this data register rotates yani continuously. As yani it goes to the 7 number, after this will be go back to the other one number. Yani for example, in at the one conveyor you are using yani 8 bottles or something. When its data reaches at the M0.7, sorry, M1.7, after it will be go back reverse forward. Yani there is a fixed yani when you're using that things, after this will be go back to the first. As you give that next, first have to be make 0, and then you make to the next, it moves into the next yani. See, it's come back. This little make we have to make correction. First we have to be stop this one simulation, and here we used 1.4, and this we have to be make correction M1.5. this we have used to M1.6, and that we have to be use M1.7. that's we next. See, when I write it here M1.8, it will be not stop, because he says that 1 point data bit is not have, because of total in 1 byte total have 8 bits. That's so finish yani M1.7 is the last. When you like to using next one, you have to use it here M1.0, sorry, M2.0, because of here that this, oh sorry, this 12.0, right, M2.0, because of this serial finishes at the 1.7. when next you start, you have to start from M2.0. as the serial you can be continue in the program. Now one more thing, now we use this one. First we use this ROR, and now we used ROL, because of this right to left. First is moving right to right, now it's moving right to left. Same this program you can use all this release as working as same condition. Basically my opinion is what yani you have to be understand why this ROR command have to be used inside the program, and where we can use when you're making the logic. After you can use this all commands. See, when I give the signal, first I have to be stop this one, it's now here, can see, and when I give the one more signal, see, it's go back. When I give one more signal, it will be come at the first one, and as I give him the one more signal, it will be rotate first. First it starts from M1.7, now it starts from M1.0, M1.0, and as I give next signal, it will be go to the M1.1. that serial wise you can use any in the program. First one running when after another signal coming, after it goes shifts into the second relay. When you giving one more signal comings, it will shifts in the next relay. When one more signal comes, it will goes the next relay. Same as when last relay will be runs M1.7, after it will be rotate back from start from Q0.0 or M1.0. Then I will show you. We will give the 7 signals. First 0, 1, and go to the M1.2. When you give the one more signal, it will goes into the M1.3. When you're giving one more signal, it will goes to the next one. As you give next signal, it moves to the next. As you give another signal, it goes into next. One more is last remaining. As you give, it will goes to the next last Q0.M1.7. See, as you give one more signal, it will be rotates and go back to the first one. See, it's come back to the M1.0. As you giving, it will goes into the next bit, moves into the next bit. So guys, I hope you understand about this ROR command and ROL command, left to right and right to left. This shift data registers you can use in the program, various program. When you're making the logic, you can think about each and every bit where you like to move. Also you can move if 2 to both. That's also I will show you. 1 second, we will stop the simulation and I will write it here. For example, 2. Now it will be moves 2 data registers continue directly inside. You have some bottles filling for two fixed bottles, 2 one size and फिर another 2 one size, another 2 one size. Same like when you're using both, it will be moves the data for 2. Make it simulation and see this. When we're giving the signal is 0, and as I give the signal, it will be goes the direct from 2. The time 1.1, it goes to the M1.3. And now next you see how it moves. As we give the signal next, it will be goes into the next 2. See, it's here coming, and one more signal when giving, it goes to the last. 0 first, and as I give the signal, it goes to the last, because it jumps at the 2, not moves in next one. It will be go 2 after another choice, here also it runs M1.7. now as I give the signal, it will be go back rotate 0 and 1. See, it's not goes into the 1, it goes into the second, M1.1. now I hope if you put it 3, after it will be, when this one is started, this one will closed, this one will closed, it jumps to the direct in 3 number. Same as any pairs, if you like to move it here, you can pair using, you can many long data you can use in the programs, which bits you like to use. This also tags, you also can give the name, this is the which number signal and which one is the signal for using this relays forward using. Also you can make the nodes here, network, which name this network is running after, easy to understand. To like to be making small, this also in network 1, network 2, when you like to using, you can make it hide and something many more. Yani, when you're making the practices in the TIA portal, after you understand about this all commands and everything, one by one, step by step, I will tell you this all commands and make it small examples in the programs. Inshallah will be next to start small examples to using that all commands. Start from logic, yani start from first, yani bit logic operations, timer operations, counter operations, comparators, and math functions, move operations. All these commands I will be use, and small logics I will make with examples and share with you. I hope you understand about this command. If not understand anything, you can send me message in comment section or send me email. I will give you feedback as soon as possible. Thanks for watching. Allah Hafiz.